Hello viewers, welcome to my channel. I'm Hasham. So far 10 problems I have completed on probability. Now 4 more problems we have to do, 11th, 12th, 13th, 14th, and these 4 problems are based on Bayes' theorem. One video I have completely explained the theory on Bayes' theorem. It's a unique method of finding out the conditional probabilities which was given by a mathematician Thomas Bayes. How to convert the prior probability into posterior probability by using additional information. Complete theory I have already explained. Hope my regular viewers have already watched. If you have not watched, go to the playlist of my channel. Select the subject statistics for management. Select the videos of probability. Third video, you will find the Bayes theorem. Now 11th problem I am going to start, 11th and 12th in this video, and the last video 12th and 13th and 14th will do it in the next video, right? Now before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Always keep it ready. Take the screenshot of the points of 11th and 12th, then I'll explain every point in detail. Now, see the 11th one. A company has 2 plants to manufacture scooters. Plant 1 manufactures 80% of the scooters and plant 2 manufactures 20%. That means out of 100 scooters manufactured by the company, 80% are coming from plant 1 and 20% are coming from plant 2. At plant 1, 85 out of 100 are rated standard quality or better. That means out of every 100 scooters produced by plant 1, 85 of them are better or standard quality. Remaining 15 are defective. Similarly, at plant 2, only 65 out of 100 are rated standard or better quality. That means the standard or better quality are different in the 2 plants. In the first plant, out of every 100, 85 are better. In second plant, out of 100 scooters manufactured, 65 are better. What is the probability that the scooter selected at random came from plant 1? If it is known that the scooter is of standard quality. Randomly, one scooter is selected from the complete scooters and found that scooter to be a better quality scooter. So what is the probability that this better quality scooter has come from plant 1? That is the first question. Second question, what is the probability that the scooter came from plant 2? If it is known that the scooter is of better quality. Now, first of all, we'll write the given information in a notational form. A1. Let us denote A1 is equal to event that the scooter is produced by plant 1. 2 plants we have, plant 1, plant 2. A1 is the event that the scooter is produced by plant 1 and A2 is the event that the scooter is produced by plant 2. B is the event that the scooter is a better quality scooter, right? So A1, A2 and B, these are the notations I have given. Now prior probability. The prior probability P1. So P of A1 and P of A2. What is the probability that the scooter is coming from plant 1? A1 means plant 1, A2 means plant 2. So what is the probability that the scooter is coming from plant 1? 85%. It is given in the 80%, sorry. 80%. Because 80% of scooters are produced by plant 1 and 20% of scooters are produced by plant 2. Plant 2 is denoted as A2. So P of A1 80% and P of A2 20%. Now conditional probability. That means what is the probability that the scooter is better quality from plant 1 and what is the probability of better quality from plant 2? That means P of B. B stands for better quality given that it is coming from plant 1. So in plant 1, out of every 100 scooters produced, 85 are better quality. 85 are better quality. So P of B given A1 is 85 and P of B given A2, that means second plant, is 65%. So 0.85 better quality from plant 1, 0.65 better quality from plant 2. Now joint probability. Joint probability is multiply the prior probability and conditional probability. This prior, this conditional, if you multiply, you will get the joint probability. So P of A1 into P of B given A1. P of A1 is 0.8. P of B given A1 is 0.85. 0.8 into 0.85, 0.68. This is the joint probability. Similarly, P of A2 is 0.2. P of B given A2 is 0.65. 0.2 into 0.65, 0.13. The total of the joint probability is 0.81. So, prior probability and conditional probabilities are given in the problem. We have multiplied and we have calculated joint probability. Now we'll attempt one by one. The first question, probability that the scooter selected at random comes from plant 1, given that the scooter is a standard quality or better scooter. What is the probability that the scooter is coming from plant 1, given that the scooter selected is a better quality scooter? That means P of A1 given B. A1 stands for first plant and B stands for better quality. Given that it is a better quality, what is the probability that the scooter comes from plant 1? So formula P of A1 given B is equal to, numerator will take the joint probability P of A1 into P of B given A1, and denominator will take the total of the joint probabilities, the total of the joint probabilities. That means P of A1 into P of B given A1 plus P of A2 into P of B given A2. So already we have multiplied, we got the joint probability and total of joint probability. So P of A1 into P of B given A1 is 0.68 and the total of the joint probability is 0.81. So 0.68 divided by 0.81, you will get 0.84. The 0.84 is the posterior probability. What is that? P of A1 given B. P of A1 given B. The probability that the scooter is coming from plant 1, given that it is a better quality scooter, 0.84. Second question, what is the probability that the scooter selected at random comes from plant 2, given that it is a better quality scooter? That means P of A2 given B. P of A2 given B. So formula for P of A2 given B, joint probability divided by sum of the joint probability. Joint probability is P of A2 into P of B given A2 divided by the sum of the joint probability, the total of the joint probability. P of A1 into P of B given A1 plus P of A2 into P of B given A2. Already we have calculated P of A2 into P of B given A2 here, 0.13. So numerator 0.13. Denominator the total of the joint probability, 0.81. So 0.13 by 0.81, 0.16. The 0.16 is the probability that the scooter is coming from plant 2, given that it is a better quality scooter. Now note, always the total of the posterior probability must be equal to 1. Now we can check. The posterior probability is 0.84. P of A1 given B. Similarly, P of A2 given B is 0.16. The 0.84 plus 0.16 is 1. That's it. So this is the end of problem number 11. Now 12th problem. There are 3 persons A, B and C. The chances that they are selected as manager of an industry are 1 by 3, 2 by 9 and 4 by 9 respectively. So there are 3 persons in an organization and the probability that they will be selected as manager is 1 by 3 for A, 2 by 9 for B and 4 by 9 for C. This is the probability of selection as a manager. The chances that they will introduce radical change in production plan is 0.5, 0.6, 0.7 respectively. That means if A is selected as a manager, he will bring radical change in the production plan. The possibility of bringing radical change by Mr. A is 0.5. Similarly, if B is selected as manager, the probability that he will bring the radical change in the production plan is 0.6. Similarly, if C is selected as a manager, then the probability that he will bring radical change in the production plan is 0.7. So radical change depends on the selection of the manager. Whether if A is selected, it is 0.5. B is selected, then 0.6. C is selected, 0.7. These are the conditional probability of bringing radical change. It is known that there was a change in the production plan of the industry. What is the chance that it is due to Mr. A being selected as manager? So afterwards, we found that there is a radical change in the production plan. What is the probability that this radical change had been brought by Mr. A? That is the question, right? So as usual, we'll write down the prior probabilities and conditional probabilities. Let us denote A1. Person A is selected as manager. A2, event that the person B is selected as manager. A3, person C is selected as the manager. And B, event that they will introduce radical change in the production plan. So here A1, A2, A3 and B. A1, person A is selected as manager. A2, person B is selected as manager. A3, person C is selected as manager. And B is the radical change in the production plan. Now prior probabilities. What is the probability that Mr. A will be selected as manager? 1 by 3. Probability that Mr. B is selected as manager? 2 by 9. Probability that Mr. C is selected as manager? 4 by 9. These are the prior probabilities. Now conditional probability. What is the chance of change in production plan by Mr. A? That is 0.5. P of B given A. P of B given A is 0.5. And what is the probability of production change in production plan by Mr. B? P of B given A2, 0.6. The probability of change in production plan by Mr. C is 0.7. P of B given A3. B stands for radical change and A1, A2, A3 stands for Mr. A, Mr. B, Mr. C. So we got the conditional probability. Now we calculate the joint probability. Multiply the prior probability into conditional probability. P of A1 into P of B given A1. So 3 by 9. Here you can see 3 by 9. 1 by 3 or 3 by 9. Because all here denominator is 9. So here also I want to make it 9. So instead of writing 1 by 3, I can write 3 by 9. Multiply the numerator and denominator by 3. So 3 by 9 into 0.5. So 3 into 0.5 is 1.5 by 9. Similarly A2. A2 is 2 by 9. 2 by 9 into 0.6. 2 by 9 into 0.6. 2 into 0.6 is 1 by 2 by 9. P of A3 is 4 by 9. So 4 by 9 into 0.7. 2.8 by 9. These are the joint probabilities. Now we want the total of the joint probabilities. So here denominator is same. 9, 9, 9. So denominator is 9. Now add up the numerators. 1.5 plus 1.2 plus 2.8. You'll get 5.5 by 9. So 5.5 by 9 is the total of the joint probabilities. Now required. Probability that Mr. A is appointed as manager given that a radical change in production plan has taken place. Finally, it is asking you in the problem, what is the probability that Mr. A is selected as manager given that there is a change in the production plan? That means we have to find out P of A1 given B. P of A1 given B. The formula for P of A1 given B, P of A1 into P of B given A1 divided by the sum of all the joint probabilities. That means P of A1 into P of B given A1 plus P of A2 into P of B given A2 plus P of A3 into P of B given A3. The numerator P of A1 into P of B given A1 1.5 by 9. 1.5 divided by 9. Divided by the sum of the joint probabilities 5.5 by 9. Now if you reverse it, 1.5 by 9, this is in denominator. If we change it into numerator, multiply. So multiply, if we do 9 divided by 5.5. So 9 will get cancelled. So 1.5 divided by 5.5. You will get 3 by 11. 15. 1.5 divided by 5.5. If you multiply numerator and denominator by 10. So what will happen? This will become 15 by 55. I am multiplying the numerator and denominator by 10. So 1.5 into 10, 15. And 5.5 divided by 10 will get 55. So 5 3s are 15, 5 11s are 55. 3 by 11. The probability that Mr. A has been appointed as manager, given that there is radical change as brought, is 3 by 11. So 3 by 11 is the probability that Mr. A is selected as manager, given that there is a radical change in the production plan. That's all. So these two problems I have completed 11th and 12th problem on Bayes theorem. In the next video, we'll complete all the problems on probability, that is 13th and 14th, 2 more problems. So if you are satisfied with my lecture, give a like to the video. Share my channel among your friends, among your group, so that more students can watch the video and enhance the knowledge. Give your comments. Subscribe if you have not yet subscribed to my channel. And lastly, buy the super thanks which is given below my video. Inshallah, we'll continue the next problem in the next video.